Don't forget to subscribe our YouTube channel and hit the bell icon to get notified.
Newton's second law of motion. This law helps to measure the amount of force. We are going to derive force is equal to mass into acceleration. First, initial momentum. Already we have discussed what is momentum, right? Momentum is represented by the letter P is equal to mass into velocity. Initial momentum, what is the formula for the momentum? Momentum is equal to mass into u. U is nothing but initial velocity. As I have written initial momentum, I am writing velocity also initial velocity. Then final momentum. What is the formula for the momentum? Mass into velocity. But what we have written here? Final. So I am writing V. V is nothing but final velocity. Change in momentum. Change is nothing but the difference. Change in momentum is equal to final momentum mass into final velocity minus initial momentum mass into initial velocity. From the Newton's second law of motion, the force acting on a body is directly proportional to the rate of change of linear momentum. Force is directly proportional to the rate of change of momentum. Rate of change of momentum is nothing but with respect to the time. So we can write it as force is directly proportional to the change of momentum by time. Rate with respect to the time. All will happen with the certain time. Okay. Now so, force is proportional to change in momentum. What is the change in momentum? Final momentum minus initial momentum with respect to the time. What we will do to remove the proportionality symbol? To remove proportionality symbol, we have to include one constant next to the equal to one constant. I am taking capital K as a constant. M into V minus mu divided by T. See here, you can take M common out. V minus U divided by T. We know the formula for acceleration. Acceleration is equal to change in velocity divided by time. Change in velocity divided by time. Change in velocity is nothing but final velocity minus initial velocity divided by t. So instead of v minus u by t, what can we write? Acceleration. Why? Because the formula for acceleration is equal to v minus u divided by t. So F is equal to, I am writing K, M, instead of v minus u by t, I am writing A, where K is proportionality constant. We can consider constant as 1. So F is equal to M into A. From Newton's second law of motion, we have derived force is equal to mass into acceleration. We all know what is the unit for the force? Unit for the force is Newton. One more unit we have, unit of mass is kg, unit of acceleration is meter per second square. So unit of force apart from Newton, we can also write kg meter per second square. This is very important 1 mark question. I will give you one small example to make you to remember that force is equal to mass into acceleration. A person is traveling in a car Unfortunately, the car is running out of petrol. So, the person is coming out of the car and he is applying what onto the car? He is applying the force onto the car. The car is nothing but an object. All the object will have a mass. So, he is applying the force on a mass. Once he is applying the force, the car started accelerating. So you can easily remember that force is equal to mass into acceleration. Force is equal to mass into acceleration. This law is also known as law of force. Why? Because this law is used to measure the amount of force. Newton's third law of motion. Very easiest law when compared to Newton's first law and Newton's second law, and very easy concept to understand. For every action, there is an equal and opposite reaction. It is very easy to understand. I am going to give you an example. A man is swimming. Okay. When he swims, he pushes the water backward. That is, this is said to be action here. The water pushes the swimmer in the forward direction. This is said to be reaction. So, for every action, there is an equal and opposite reaction, so that the swimmer starts moving forward.